Ladies and gentlemen, this is Kim Greenhouse. I want to welcome you to It's Rainmaking Time. We've done many segments on weather and climate, and one of the concerns that I've had for many years has been the rise in sea level. This was the image in my mind. This is what I read in Al Gore's book and in the movie An Inconvenient Truth that scared me the most. And because it scared me the most, it's actually been one of the last aspects of climate change that I've been willing to look at. And we're here, we're looking at it, and I have read about and contacted Nils-Axel Mörner, who has his background in geology. He was head of the unit of paleogeophysics and geodynamics at Stockholm University. He's organized 2 major international conferences, one on Earth rheology, isostasy, and eustasy. In 1977, he has been the president of the INQUA Commission on Sea Level Changes and Coastal Evolution. He also headed the INTAS project on geomagnetism and climate. He has really been kind of the main point person in the world on everything related to sea level and the sea. In 2008, he was awarded the Golden Chondrite of Merit from University of Algarve at an international sea level meeting in Portugal for his irreverence and contribution to our understanding of sea level change. For those of us who have really accepted the information that the sea level is rising, what he's about to share with us today will definitely stupefy you. For others, it'll calm you. For others, it will mystify you as to why someone who spent his life on this is telling us the direct opposite of everything the IPCC, Al Gore, the supposed people who understand this matter. We will have a major change of heart. Ladies and gentlemen, please welcome Nils-Axel Mörner to It's Rainmaking Time. Good morning.
Good morning. Thank you very much for this very nice and correct introduction.
I want you to share with us, firstly, how it is in your field that you have measured sea levels and their changes so that we have a frame of reference for audiences about where you're coming from and how this is traditionally done.
Yes. May I just say something from the beginning? In the beginning of the 1990s, the IPCC started off, and I think it headed almost immediately in the wrong direction, just to prove that the anthropogenic effect had set the changes we are measuring. So in 1991, I was invited to Washington at the American Association of Advancement of Science to talk about sea level changes. And I said that sea level is not rising, because that was the evidence from the field. And the IPCC people, and especially the president, Bolin, was very angry about this. But it couldn't be helped. I continued with my writing, scientific papers. But in 1999, there was a big IPCC review, and they asked me to be the expert reviewer. And I was so, and I was very surprised. First, to see the very low quality of that chapter on sea level. Secondly, even more surprised I was because it was written by 33 authors, but not a single one was a sea level specialist. They were taken from other disciplines because they were loyal. And of course, that upset me very much. At exactly that moment, I had become president of the INQUA Commission on Sea Level Changes and Coastal Evolution. We had about 300-400 of the top sea level specialists in the world. So I took it to our commission. Please, have your opinion. Let us go through this. What should we, as sea level specialists, say, contrary to what IPCC say? So we had it up at 5 international meetings. We had it up in our networking and our homepage. And we came to a conclusion that in 100 years, I mean, it's in 2100. Maybe sea level could at the most rise, and listen, 10 centimeters.
And what does that mean?
Stories of 10 centimeters. 10 centimeters plus and minus. That is just nothing.
Well, what is 10 centimeters?
And later we have even updated it, because in a very short while, or in 30 years or so, we will be in a solar minimum, and it will be cold again. So then sea level may go a little down. So we say 5 centimeters plus and minus 15. So that is nothing to worry about. And that's the beginning. At the same time, but you shouldn't just say things. You must go out in the field and prove it. And this is typical for sea level people on geologists instead of meteorologists. Meteorologists sit at computers, and we are in the field. So we started international field study on sea level changes in the Maldives, because all people said Maldives will be gone, wiped out from the surface of the earth, or surface of the water, as a matter of fact, because sea is rising, and in 50 or 100 meters, they said, they domed it had to be flooded. So we started to work there, and very soon we saw that no, for heaven's sake, there is no trend here. Sea is not changing in any way. I mean, we worked in the attacked coast, in the lee sides of the coast, in lagoons, in lakes, in offshore cores, all kind of environments. And wherever we worked, we got the same answer. No problems. So, and then I published this. And I have continued the work. And I launched a little booklet with what I say with a modest title, The Greatest Lie Ever Told, because there, with observational facts, I wanted to show that what the others are claiming is simply not correct.
Can you explain to us, in your field, how is the sea change measured traditionally? What do you do when you're in the field, when you're measuring if the sea is rising or not?
Okay. There are different ways of doing it. One way is putting in what is called a tide gauge. It's really a measuring rod usually at the port. But remember, usually that gauge is sitting on a very heavy harbor construction of concrete. So very, very often it doesn't show any rise of sea level or so. It shows also the compaction of the sediment underneath the big concrete mass. So we can get some direction, but it's not straightforward. The other is nowadays satellite altimetry, which is a wonderful tool because it measures even the middle of the oceans. The thing is that you have to calibrate it in a correct way, and you should certainly not add personal calibration in order to make it fit your expectations. And that's what people have done. What we are doing as geologists, we go to the actual coast and we look at the morphology. I mean, what happens there with the waves and the long term. Then we look at the stratigraphy. We cut, please, and see how the sediments are being deposited. For example, is it erosion? Most people say if the coast is eroding, they say, sea is rising. Very seldom this is the case. Much more common it is that the sea level lowering causes heavy erosion. And the material being put in mobility, you go to the lee side, and there you see if it's put attacking the former coast or if it's putting at a lower terrace. And then it's a long term. You can measure it within centimeters, even better. So it's a very sharp thing. And lagoons are perfect because